Hello viewers, you're welcome to my YouTube channel. This is X tutorial, and in today's lesson we'll be evaluating limits by L'Hopital rule. We've earlier talked about the different kinds of methods to evaluate a limit. So in today's video, L'Hopital rule is our focus. The L'Hopital rule is a very powerful method of evaluating limits in that it uses the tool of differentiation to evaluate a limit. L'Hopital rule in itself is designed to evaluate limits of the form 0 divided by 0 and infinity divided by infinity. So these are the two indeterminate forms that L'Hopital rule evaluates. But then, how about other forms of indeterminates? It can actually do so, but then you will have to combine it with powerful tricks like using logarithmic trick or using some sort of algebraic simplification. So in this video, let's see how we go about the questions on the board. So for question number 1, the limit of e raised to the power of x minus 1 divided by x as x approaches 0. So for x approaches 0, definitely you have e raised to the power of 0, which is 1. 1 minus 1, 0, divided by 0. So this means that the direct substitution cannot work. But then let's see if we can simplify. The function you have there is a special function, e raised to the power of x. Special functions, you cannot simplify that any further than that. And that means you cannot also use the method of simplification. So we then resolve to the method of L'Hopital rule. How do we go about that? So let's go. So the limit of e raised to the power of x minus 1 over x, let's differentiate. Now there is a difference between differentiating this function as to suit L'Hopital rule and differentiating this function like your normal derivative. So for this, you're not going to use differentiation by quotient rule. No, you're just going to differentiate the functions as two independent functions, right? So if I differentiate e raised to the power of x, if I differentiate my numerator, I will get e raised to the power of x. If I differentiate it, it gives me e raised to the power of x. And if I differentiate 1, I will get 0. So which is just e raised to the power of x minus 0 remains e raised to the power of x. Divided by, if I differentiate x, I will get 1. So dividing by 1 means nothing. Yeah, so this is e raised to the power of x. Right? So now I can now take the limits of the function that I have. So I have the limit of x approaching 0 for e raised to the power of x, right? And if I put x for 0, then I have e raised to the power of 0, which is equal to 1. Therefore, the limit of e raised to the power of x minus 1 divided by x as x approaches 0 is equal to 1 by method of L'Hopital rule. How about we evaluate question number 2? Let's see what it will look like. So for question number 2, we have the limit as x approaches 0, x ln x. So if we do that, you would not be able to use the direct substitution for this, and you cannot also use the simplification for this because this is a special function, ln x. Ln x is a special function. But if you look at this question and the one we just finished, they are different. How? They are different in the form that question number 2 that we are evaluating now. So the difference between the question number 2 and question number 1 is that question number 2 it's a product and question number 2 is a quotient. In number 2, you're having x multiplied by ln x, two functions multiplying themselves. And in number 1, you're having a quotient. E raised to the power of x minus 1 is dividing x. That's the difference. So for the question number 2, we're going to have to put it in quotient form. We have to take it to just like question number 1 is that form, that quotient form, a rational form. And how are we going to do that? This will be equal to the limit as x approaches 0 ln x divided by 1 all over x. Yes, you agree with me that this is ln x divided by 1 over x. Of course, you know that this thing, if you want to simplify this, you get x ln x just as your original function. How are you supposed to go about that? You have ln x divided by 1 over x, which you can write as ln x divided by 1 over x. And your simple rule, you can invert your 1 over x and change the sign of division to multiplication. So that becomes ln x times x all over 1. So x times ln x gives you x ln x divided by 1, which is just the same thing as x ln x. So at this point, now that you know that this is the same or equivalent as this, so let's go ahead and apply our L'Hopital rule. So if I differentiate ln x, I will get 1 divided by x. I will get 1 divided by x. A simple way you can know what your result will be when you are differentiating the ln of a function is the fact that you have u divided by u prime divided by u. So whatever your function is, let it be u, and then the derivative be u prime. So the function we have, apart from ln, what we have, the function, whatever you have there is just x. So if I differentiate x, I will get 1 divided by my function u, which is x. So differentiation of ln x is 1 over x, right? So this becomes 1 over x divided by, if I differentiate 1 all over x, what will I get? I'll get -1 all over x squared. How did that work? 1 over x is the same thing from law of indices as x raised to the power of -1. And from your rule of differentiation, this is the same thing as if y is equal to x raised to the power of n, then the y divided the x is equal to n x n minus 1. Judging with what we have here, what's our n? Our n is the power -1. So this will be equal to n, which is, what is n? -1. X, n, what is what? N -1 -1. So this will be equal to x minus 1 minus 1 is -2. And then you have your minus here from this minus. And this will give you -1 divided by x squared by bringing this power down, right? Okay, so that's how we got that. This you can rewrite in a more simpler manner. This is a complex fraction, but you can write it in a more simpler manner where you don't have too much issue resolving. So this will be equal to 1 over x divided by -1 all over x squared. And like we know, you can invert your right hand side, take the inverse by changing the division sign to multiplication. If we do that, we are going to have 1 divided by x times x squared divided by -1. X and x will cancel out, leaving you with negative of x because of this -1, right? And so if we take the limits from here, what we have now is just the limit as x approaches 0 for what? -x. And what's our x? Our x is 0. So this is equal to 0. So the limit of x ln x as x approaches 0 is what? Is 0. Let's try and see how we can go about question number 3, which is going to be our last question for this video. And then I will leave you with 2 questions to try on your own. So for question number 3, I'm going to rub this part of the board. And in a bit, I will rub on that side also. So I have limit as x approaches 0 for 1 divided by sine of x minus 1 divided by x. Of course, if you substitute 0 here, you're going to have a problem you're not supposed to divide by 0. It's an indeterminate. It's something we've not been able to wrap our heads over, even as mathematicians. So I'm going to simplify this so that my L'Hopital rule can work. So this will be the limit as x approaches 0 into x minus sine x divided by x sine x. What I did there is called the butterfly method of resolving fractions. So if I simplify what I have x minus sine x divided by x sine x. Even at this point, if you substitute 0, you're going to get an indeterminate form of 0 over 0. That's why we have to use the L'Hopital rule. Let's go. So differentiating my numerator, this will give me the limit of x approaches 0. If I differentiate x, I'll get 1 minus, if I differentiate sine, I'll get cos x, all divided by, to differentiate x sine x, its product. So you're going to differentiate that using the product rule. And the product rule says that if y is equal to uv, then the y divided the x will be equal to v du over the x plus u dv over the x. What is your u? Your u is your first function and your v is your second function. So u in this case is x and v in this case is sine x. So I'm going to be using the product rule to do this differentiation. So differentiation of x sine x is going to give me x into differentiation of sine x, which is cos x, minus, okay, plus from my rule, plus sine x into differentiation of x, which is 1. By simplifying, this is the limit as x approaches 0 for 1 minus cos x divided by x cos x plus sine x. So let's see what our answer will be by direct substitution, now that we have used the L'Hopital rule. So by direct substitution, 1 minus cos of 0, because x approaches 0, right? So 1 minus cos of 0. Cos of 0 is equal to 1. So 1 minus 1 is 0. And I have x cos 0. X is 0. So cos of 0 is 1. But 1 times 0 is still 0. Sine of 0 is what? 0. So 0 plus 0 is still 0. So I'm still having what? The indeterminate form of 0 divided by 0. I need to go over it again with L'Hopital rule. So the L'Hopital rule does not mean that it's a one-time of something. No, you have to keep on the process. The process has to be repeated till the point where you get your expected results. Something that can easily be handled by direct substitution. So let's use the L'Hopital rule again. Using the L'Hopital rule again. So using the L'Hopital rule again, I'm going to have the limit as x approaches 0. So if I differentiate 1, I will get 0. If I differentiate cos, I'll get minus sine x. But there is a negative here. So minus minus will give me plus. So that will be sine x. So this is sine of x divided by, if I differentiate x cos x, that's product, right? Same thing we did here. So I'm going to be using the product rule just like what I did already. So this will be x multiplied by the derivative of cos x. That will be minus sine x. So this is minus x sine x plus cos x times the derivative of x. That will be cos x times 1, which is cos x. And if I differentiate sine, I will get cos x plus cos x. So by simplifying, this is limit as x approaches 0, sin x divided by minus x sin x plus 2 cos x. Cos x plus cos x is 2 cos x. So let's substitute our x for 0 and see what's going to be the outcome. So for x equal to 0, sine of 0 divided by minus 0 sine 0 plus 2 cos 0. Sine 0 is equal to 0. Whatever this is, for the fact that I'm multiplying it to 0, is definitely 0. So this is 0 plus 2 cos 0. Cos of 0 is equal to 1. So 2 times 1 will give me 2. So this is 0 divided by 2. And this is equal to what? 0. Once you divide 0 with any number other than 0, then your result is actually 0. So 0 divided by 2 is equal to 0. And that is what it looks like by evaluating with the L'Hopital rule. But I'm going to leave you with just this question so you can try it, and then you can leave your solution at the comment section. Okay, so just try this. The limit as x approaches 1 for x raised to the power of b minus 1 divided by x raised to the power of a minus 1. Leave your comment section, your solution at the comment section. Up until I come your way again, this is X. Don't forget to like, don't forget to subscribe, and don't forget to hit the notification button so that when next videos are dropped, you will see it. Thank you.